why typing sucks now.
I spent 100 days typing with the worst keyboard on the planet.
What?
With its characters rearranged by artificial intelligence.
Oh, AI made this. What is this? Is that an I? Oh, wait. A-E-I-O. Where's you? Okay, there's you. It's like the numbers got moved down mostly, except for B and the 7 ampersand. Oh my God, why is this? Why is this how it is?
To cause me as much pain as possible. Along the way, I learned how QWERTY came to be, some of the pitfalls of optimization, and I even got a bit better at typing. However, this was still a terrible idea. I've always wondered why our computer keyboards follow the QWERTY layout, rather than something more logical, like maybe A to Z. I had heard that it was to stop old typewriter keys from jamming, but that's not entirely correct. If you could ever point to the world's first keyboard, then this would probably be it.
What?
It's called the printing telegraph.
Oh, that thing's
and
huge!
It was invented in 1846 by the electrician R.E. House. Like with a regular Morse code telegraph, it can send long-distance messages along wires. But unlike with Morse code, which uses dots and dashes, this one could send entire letters. It's written out A to Z, which, yeah, sort of does make sense, but is also incredibly inconvenient to use. In 1855, pianist David Hughes took advantage of people's familiarity with piano keyboards to create this thing. Effectively, it's the house machine just folded in half. The black keys are the letters A through to N, and the whites O to Z.
Oh, look how bouncy they are. Oh, wait, did he just make this? That's crazy.
Now, the real thing didn't actually play music, but if it could, then the sentence...
Wait, did he... It looks like he 3D printed all this. That's so cool.
would sound a bit like that. The next improvement came in 1868, when engineers Scholes, Glidden and Soule took apart one of these Hughes machines to use as their foundation for their typewriter.
All right.
The rectangular piano keys were switched out for rounded buttons, and the vowels pushed up to their own row. Symbols were added in, although the letters I and O were made to double up as 1 and 0. The keys were pushed together and rows staggered to leave room for mechanical links.
V3.
In 1870, the trio tried to sell this design to American Telegraph Works as a way of allowing their operators to transcribe messages rapidly. As an added bonus, the telegram would now actually be legible. American Telegraph loved this design, but asked for a couple of modifications to make things even faster. The letter I, moonlighting as the number 1, was moved next to 8, so that the year 1870 could be written rapidly. In Morse code, the letter Z is often confused with the sequence S, E, so those letters were moved close together. Frequently used characters were pushed to the easy...
Wait, if they were so confusing, why would you push them together?
...to reach middle of row 2, while those used infrequently were moved to the edge.
Oh my gosh. And now, wait. Are we here finally? Oh, wait, no, not completely. Wait, I got like a 60% keyboard. This is like... is this it? No, because like M is like right there. But on my keyboard, M's like down here under K.
The fact that you can now spell typewriter using just the second row of a typewriter was of course entirely coincidental. Soon, other manufacturers copied this design, reasoning that if people were familiar with the Scholes layout, then they'd probably want to have something pretty similar. However, in order to avoid patent infringements, they needed to mix around a couple of the characters, purely by accident.
Okay, yeah, just you can copy my homework, just don't make it look exactly.
Someone accidentally invented the QWERTY layout that today we know and love. Eventually, an agreement between the major manufacturers standardized things to QWERTY, and more than 125 years later, it's still being used on everything from laptops and smart fridges to the clicky-clacky desk candy of r/mechanical keyboards.
Oh, yeah.
This process replicates what AI researchers like to call a hill climbing algorithm. We start out with a certain keyboard configuration, and then you, as an innovator, come along and make a small change. If the change results in a worse keyboard,
Oh, Jesus.
then no one will buy it, and your company goes out of business. However, if the change is beneficial, then people will buy it, and the next innovator who comes along will make a small change based on your improved keyboard design.
You know what's funny is like, you don't need like any dexterity, like finger dexterity to do this, but each iteration you need more and more, I don't know, finger dexterity, skill, precision, because the buttons are getting smaller and more buttons are just jumbled up together. So is the next layout going to be something like maybe like instead of 4 rows, maybe it's like 5 rows and it's like a square?
Like climbing a real hill, we only ever take steps toward the top, and at the top of our keyboard hill is QWERTY. Unfortunately, one of the problems with this hill climbing approach is that by making small changes and getting a constantly better solution, sure, we might be able to get to the top of a hill, but chances are that there is an entire mountain just over there, which we can never reach.
It's relative.
Because to get to that objectively better solution, we first have to climb back down.
Yeah.
QWERTY isn't just suboptimal. It might also be actively dangerous. I've got here a sort of heat map, with the blue and green keys the most popular, and the reds the least. QWERTY shoves a lot of the popular keys up top.
Wait, is this like the Wheel of Fortune letters, like R, S, T, L, N, E? Like R, A, H? Yeah, this is pretty much the last couple letters, or like at least the most popular letters used on like every what was it, like Wheel of Fortune puzzle. They just give you R, S, T, L, N, E because these letters are used so much. And then I would have to imagine if you apply to that show, you're trying to game the system by watching like some Wheel of Fortune statistics of like, oh, what letters statistically could come next, and then from that, you know, we're just gonna try to make our best guess and whatever. And Wheel of Fortune has been on for so many years now. The producers probably know that people are gonna do that, so they probably have to take a step ahead of that and come up with like wonky words or phrases to undermine what people are going to do to try to get like a leg up on solving a puzzle or something like that. Which is really funny because that's how the World of Warcraft like raid design team does raids. The devs just constantly trying to make a harder and harder fight so that the top 1% of players can't design add-ons quick enough to do the fight, which is so funny. Oh man, it's just, I don't know, when you heat map it like this, there's just like so many thoughts pop out. So what isn't used? Q, Z, X. Ooh, those are the like the high value words or letters in Scrabble.
Which means that from their home position, your fingers really have to stretch in order to reach them. A lot of the stretching is diagonally, and your fingers and hands are being used super unevenly.
Oh.
Your left middle finger is being used way more than the right one.
Bro, he literally just made this so he can like just flick off the camera. All right, dude.
With this in mind, it perhaps comes as no surprise that keyboards cause nearly 500,000 injuries per year, in the US alone. Most of these are from repetitive strain, but also from that one guy in Kentucky who attacked his neighbor with a typewriter.
Oh, that's funny.
Not much you can do about attack typists, but given a blank slate, could we redesign QWERTY to reduce these injuries? And for that matter, could we make it so that it's so egregiously awful it gives you arthritis just by looking at it? Only one way to find out. To begin, we'll need to define what good and bad actually mean in the context of keyboard design. This is what machine learning engineers like to call an objective function.
Bro, I feel like this guy is about to propose like a new layout for the standard keyboard.
My first assumption is that it's better if your fingers have less distance to travel.
Right.
When you're typing out a letter, your fingers need to move to their new position, adding in a certain amount of distance.
Yeah.
My second assumption is that it's really annoying if the same finger has to move to multiple keys in a row. For example, typing out a full stop at the end of Romeo means that your right ring finger needs to move from the O to the stop. I also considered the relative...
And I'm just gonna go off on a limb, and he's probably saying, like, people that use formal typing techniques. Because, like, I got a keyboard and I could type, but it's very informal. Like, I'm looking down at the keyboard. I just muscle memory a lot of the things. I can go, like, decently quick, but nothing. I would say I'm, like, average to probably below average in terms of, like, typing speed or something. I don't even know.
Annoyance of using each finger, which I tested out by seeing how many times each finger could click its home key in a minute. It turns out that my left ring finger is really terrible at this, and we'll see if that affects the optimization results later on. I've scaled...
So it feels like he wants to put the most used letters like on the right side and more towards the center is kind of what it feels like.
Each of these factors so that they give an equal contribution to our final score, and have scaled that score based on QWERTY. Using these assumptions, alphabetical order is 1% worse than QWERTY, which makes sense, given that QWERTY is just alphabetical order with a couple of keys mixed around. Ortholinear, where the keys are vertically arranged, scores 0.3% better than staggered, which is actually remarkably small.
Bro, I am just being introduced into the world of typing. I didn't even know keyboards could go like straight up and down. Ortholinear? It's QWERTY, but just straight.
And because it's so hard to make and get an ortholinear keyboard, I've actually kept with staggered with most of my optimizations. Obviously, I'm not the first person to try optimizing keyboard layout using science, and the most popular QWERTY alternative, known as Dvorak, based on letter frequency,
I've heard that before.
A 26% improvement. That's fantastic, but I think we can do better.
Even better.
If you were to build and then line up every single possible keyboard permutation, then you'd form a row stretching from here in Boston to New York City.
Dang.
And then, around the observable universe, 500 billion times. Rather than getting an unpaid, overworked, sleep-deprived, caffeine-addicted PhD student to test out all those different keyboards,
fair.
Another option is to get the computer to do that for you.
Yeah.
With what's called machine learning.
Oh
Today,
boy.
I'll be using a specific approach known as simulated annealing, which will hopefully prevent us from needing to test out all of those different options. In the world of material science, annealing is when we heat up a metal and then slowly cool it back down, which allows the atoms to gradually rearrange themselves in a more optimal, low-stress configuration.
All right.
We can apply this same concept to keyboards, to slowly rearrange their keys and relieve the stress from our fingers.
So he's just using the term like annealing, but it's just like trial and error times a bazillion.
We start out with a random arrangement of letters and numbers and a simulation temperature of 500 degrees. It'll cool down later on, but 500 is where we start. Based on this current temperature, we're going to remove a certain number of keys. Since it's 500 degrees, let's say that's 5. We then shuffle them out and we put them back in a completely new and randomized arrangement. After our shuffle, we compare the new keyboard to the old one. If the new keyboard is better than the old one, then we'll keep it and use it as the basis of our next shuffle.
Ooh.
In this way, it's the same as the hill climbing algorithm from earlier. If, on the other hand, it's worse, then the genius of the simulated annealing approach is that there is a chance we'll still keep it anyway. We tie this probability with the current simulation temperature. Near the start of the simulation, when temperature is high, there's a high chance that we'll keep a worse design. Whereas near the end of the simulation, when things cool down a bit, then the chance of keeping a worse design is much lower. Looking at this through the lens of hill climbing, it's as if we explored the base of lots of different hills, but then only ended up climbing the tallest mountain. I wrote this out in code and had our objective function type out all the works of Shakespeare.
Oh, this is cool.
At the start, we have big swings in score.
Bro, you know what this reminds me of? This reminds me of that, what is this? The satisfying, arranging thing with the bars and shit, where it's like, and it arranges the bars in a shitload of different ways. I forgot what the name of the video was called, but this literally just reminds me of that, but for typing.
As we're accepting pretty much all the different keyboards, even those that are definitely worse. However, over time, as the simulation cools, we have a more consistent increase, although still with the occasional dip back down.
Ooh, look at the plateau.
After 2 days of simulation time, we've got it. a keyboard that is 39% better than QWERTY at writing out all the works of Shakespeare. My right index finger has immediate access to the letter E, as well as other popular characters.
Wait, he just made the thing good for writing Shakespeare, but nobody talks like Shakespeare today.
And my left ring finger barely has to do anything at all. To get more insights, I also looked at other classic pieces of literature, like every single comment this channel has ever received, the top 100 Wikipedia articles of all time, and the script for the B-movie.
Yeah.
This is our YouTube keyboard, Wikipedia, and the B-movie.
Oh my god. Oh, he made a keyboard for each move, each thing?
Like with the Shakespeare keyboard, but unlike with QWERTY, the popular keys are almost always in the home row.
Okay.
Looking at finger frequency, you can see a definite bias for using my stronger fingers. Of course, the whole reason for using a keyboard is to write actual words, and it's here where we see the biggest improvement. Frequently used words like the in Shakespeare, internet on YouTube, edited with Wikipedia, and honey in the B-movie all see significant improvements. We can also play around with a couple of our assumptions. If you're writing a YouTube comment, then chances are you're on a phone, and optimizing for a 10-finger typing pattern
Oh
is
my god. I didn't even know you could do this on your phone, dude.
actually a bit silly. With just the thumbs, this is what our digital keyboard should look like. Optimizing for XY positions on the Wikipedia training set gives us this mess.
What?
AI has no respect for my joints. All of this is great, but completely disregards the fact that learning a new layout sucks. To take this into account, I use the B-movie to create what's called a Pareto frontier, which indicates the best keyboard layout for the minimum number of key changes. If you can only make one switch, then E and J gives a full 13% improvement, with basically no effort.
Huh.
But if you're a little more daring, then this 8-key version gets you all the way to a 31% improvement. So we've got the code and run it through its paces in creating better.
Bro, I love how this guy is just, whenever he's on screen, he's just in some, like, behind a waterfall, in front of, like, a pond. That's, like, the best part of the video,
keyboards.
dude.
But what if you wanted to make the world's worst? Well, actually updating the code was remarkably simple. I just changed a greater than sign into a less than sign.
Oh.
However, I wanted to train on something that's a bit more personal than just all the works of Shakespeare. How often do I have to write out that? So instead, I took every single assignment that I've ever submitted for university, 3 years of email data, and I just tracked my key inputs for 2 weeks in order to create the greatest training set of personal data that has ever been made. And no, you're not getting a copy of it. With a bit of training, we get this. The worst.
Wait, what is this? Is this the one that he, like, showed in the beginning? Oh my god. Well, I would imagine when you're in college, you're probably typing out words and symbols that you wouldn't normally use in just everyday life. So there's probably some level of bias here, but I mean, that's fair. Whatever.
Keyboard on the planet if you happen to be me. Writing on this thing isn't fun. On the evening of the first day, my tendons were sore, and after the first week, my left wrist was actively painful. Mentally too, it was a bit of a challenge, and I could practically feel my neurons rewiring themselves. Now, normally I'm pretty average at typing at 60 words per minute, but the new layout dropped me down to just 6.
Oh.
Over time, it did improve, and I could get to about 30 words per minute at the end of 100 days.
Okay.
But it's still not great. I think overall, a good analogy would be like wearing gloves. At the beginning, these were big, chunky gloves, making it really hard to type. But
and on top of it, you're having to have your eyeballs down at the keyboard. So like, I've never taken like a formal typing class, but I know like some of my friends did, and the techniques that they would use in there are just so like wonky. Like I attempted to learn how to type, like formally, and I was it originally they had you use like just one row, and they just have you type out words using like the home row, and then like it was like done in levels. Like the next one, it was done with like just type out words and repeat letters, with the top row, do it same with the bottom, and then incorporate the home row in the bottom row, and then the home row in the top row, and then eventually, you know, the whole keyboard. But it's just a lot of repetition, really.
Over time, my brain could mostly compensate, and writing became a bit more natural. There were exactly 2 benefits to this new arrangement. First, finding the key you're looking for is super easy, because all the popular characters are exactly where your fingers aren't.
Oh.
Another benefit is that it really gave my weaker fingers a workout. Normally, I prioritize just my pointer and middle finger, but now the others were being used as well. It's been 100 days and I'm back to QWERTY, but now I type using my entire hand. My left ring finger still sucks, but just that little bit less. At the end of the day, would I recommend fully optimizing your own keyboard? No, learning the remappings is incredibly painful. Did I leave a copy of the code in the description anyway for you to try yourself? Yeah, of course I did. Let me know how it goes. In the meanwhile, I created an entirely editable, bird-safe version of the world's worst keyboard.
What the heck? Is this just bread or toast?
Which I'm very much looking forward to throwing into the Charles. Perhaps the geese can find a better use for it. This has been James Dingley from the Atomic Frontier. Keep looking up.
Oh my god. That's so funny.
Feast, my child.
Oh man. Oh, this is pretty cool. I liked it. Yeah. I mean, the thing is, like, yeah, it's really cool to have like your own customized keyboard, but I think everybody has been raised, or at least I don't know, everybody I know like has been raised just using a QWERTY. It's just like the norm. And you just have to, I don't know, get good if you want to like try to increase your like words per minute or whatever. But no, I like this little experiment. I thought it was cool to try to figure out how to customize everything and whatnot. Definitely. I mean, I'm a fan. But yeah, that's pretty much it for me. And I'm excited to see if there's anything else. But yeah, I'll catch you guys on the next one. All right, later.